Hi guys, I hope you have seen this kind of gate valve used in the water pipe connections at your home. The main function of the gate valve is to limit the flow of water in the pipe. There is a small gate present inside this valve which can limit the flow of water. That is why this is known as a gate valve. Okay, let us represent this gate valve diagrammatically like this. Here you can see there is a pipe and there is a piston like gate which can move up or down. When it is moving up and down, it can limit the flow of water. We have seen that we can use a gate valve for limiting the water flow in a pipe system. Similarly, in electrical circuit, the device which used to limit the flow of current is called a resistor. Limit the flow of current is called a resistor. I have shown the picture of a resistor here. In fact, we can draw more analogies between current flow and water flow. Analogy means the functions are same. So if we consider the function of a gate valve is analogous to the function of a resistor in a circuit, we can say that the speed or pressure of the water in a pipe system is analogous to the voltage or potential difference in a circuit. Okay, now with this idea in mind, I am trying to introduce an important concept in physics which is known as Ohm's law. Consider a two-tank system as shown in this picture. Here you can see that there is a tank A and tank B which are connected using a pipe. Let us call the level of tank A level 1 and the level of tank B is level 2. So you can see that the level of tank A is higher than the level of tank B. So it is clear that the water will flow from tank A to tank B through this pipe since there is a pressure difference. So I have shown there is a pressure difference between the two tanks. So this pressure difference is created because of the level difference. So because tank A, the water level at the tank A is at a higher potential than the water level at tank 2, and we know that the water will always flow from a higher potential to lower potential due to gravity. In fact, that is the basic idea behind the water tap in our home. We will get water through this water pipe because we have a water tank at the top of our terrace. Since there is a potential difference between the water tank and the tap, we will get the water through the pipe. Similarly, if we connect a voltage source or a battery across a conductor, I have shown a conductor here, and there is a voltage source connected across the two ends of this conductor. So the main purpose of connecting a voltage source is to create a potential difference across the two ends of the conductor. So if we are connecting a voltage source or a battery across the conductor, the electrons will flow from the negative terminal of the battery to the positive terminal of the battery through the conductor. So I have shown the flow of electrons in this picture. This is like water flowing from a higher level to a lower level. Here the electrons are flowing from the negative terminal to the positive terminal. So in the earlier days when scientists started studying about current, they thought that the positive charges are flowing from positive terminal to negative terminal of the battery. So they have taken the current flow in that direction, that is from positive to negative. So later on they found out that actually the current flow is contributed by the flow of electrons, and the electrons are of negative charges and they are flowing from the negative terminal of the battery to the positive terminal of the battery. But still, for a convention, we are taking the current flow in the direction from positive to negative. So if you see some circuits with current flow marked like this, always remember that the electrons are flowing from negative terminal of the battery to the positive terminal of the battery, but we have shown the conventional current. That current is known as conventional current flowing from positive terminal of the battery to negative terminal of the battery. The scientist who observed this relation is a German physicist. His name is George Simon Ohm. He found out that the current flowing through a conductor between 2 points is directly proportional to the potential difference across the 2 points for a given set of constant physical conditions like constant temperature and constant pressure, etc. Let us try to write a mathematical expression for this observation. What is Ohm's law? What Ohm's law says? The Ohm's law says that the current I is proportional to the voltage difference across the conductor. So we can write like I is proportional to V. And Ohm also observed that the current flowing through the conductor is inversely proportional to a property of the conductor, that is resistance. So each material has its own tendency to resist the flow of electrons. So he observed that the current flow is inversely proportional to the resistance value of the material. So if we combine this equation, we can write like I is equal to V by R. Otherwise we can take like I is equal to 1 by R into V, where we know that I is proportional to V, and we can take 1 by R as the proportionality constant, which is introduced to remove the proportionality sign from the relation. Now let us come back to our discussion about water tanks. If we want to purposefully limit the water flow through this pipe, we need to introduce a gate valve like this in the water pipe. So similarly, consider there is a voltage source V and the conductor is a perfect conductor, and we want to purposefully limit the flow of current. Then we need to introduce an electrical device called resistor in this path. So the letter used to denote resistor is R and its unit is ohm. The unit ohm is represented using a Greek letter omega. Consider there is a tank system like this, where there is tank A and tank B. The level of tank A is higher than the level of tank B, and there are 3 gate valves connected like this. The 3 gate valves are connected one after another. So this connection is known as series connection. So consider there is no gate valves, then we can see that the water will be flowing at a speed, and when we introduce the first gate valve, there will be a small drop in the pressure, and when we introduce the second gate valve, there will be some more reduction in the speed of water flow, and when we introduce a third gate valve, again there will be the reduction of speed in the water flow. So we can find that each gate valve has its own role in reducing the speed of the water. Each gate valve has its own contribution towards reducing the speed of water flow. The analogous circuit is looking like this. So here you can see the resistors R1, R2, R3 are connected in series, and the voltage supplied is Vs. So this is S is used to denote it is a series connection, and the current is flowing in this direction. We have observed in water tank analogy that each gate valve has its own contribution towards reducing the speed of water flow. Similarly, here you can see that each resistor has its own contribution towards dropping the voltage across the resistor. So let us call V1 as the voltage dropped across the resistor R1, and V2 as the voltage dropped across the resistor R2, and V3 as the voltage dropped across the resistor R3. So we can see that the total voltage Vs is dropped across all the 3 resistors. So we can say that Vs is equal to V1 plus V2 plus V3. In this series connection of resistors, we can see that Vs is the supplied voltage and Rs is the total resistor value of the circuit. Then we have seen that we can write Vs is equal to V1 plus V2 plus V3, where V1, V2, V3 are the voltage drop across the resistors R1, R2 and R3. So from Ohm's law we have derived a relation, that is I is equal to V by R, and we can write like V is equal to I into R, and if we are substituting this V into IR into this equation, we can write like what is I? We can see that there is only one current I in the circuit, so we can write like I into RS, where RS is the total resistance of the circuit, and which is equal to I into R1 plus I into R2 plus I into R3. And if you are taking I common, we can write like I into R1 plus R2 plus R3. If we cancel I from both the sides, we can get a relation, that is Rs is equal to R1 plus R2 plus R3. What this equation says? This equation says that in a series circuit, the total resistance is equal to the sum of the resistance values. There is another way of connecting more than one resistors in a circuit, and that is known as parallel combination of resistors. Let us see parallel combination of resistors with its analogy in the next video. Thank you for watching.